Let's do our first actual kinematics problem that has to do with something sliding down a plane. An object is allowed to slide down a ramp with an incline of 15 degrees for a length of 10 meters measured along the slope of the ramp. Get a picture. So I've got this 15-degree angle. Make it believably small. It doesn't need to be, you don't get a protractor out and make sure it's 15 degrees, but 15 degrees is pretty small. You should make it a small angle. And the 10 meters is specified as along the slope of the ramp. That means that I should have this length labeled as 10 meters. The first question is, what is the vertical displacement the object undergoes while sliding down the ramp? So this question right here asks about this. I'm going to call that y because it's vertical. If you look at this question with fresh eyes, you will see that this isn't even really a physics question. This first question is straight trigonometry, because all you need here is a trig ratio involving what you already know and what you want to know. That ratio is sine, because the sine of 15 degrees is the opposite of y divided by the hypotenuse of 10. So then y equals 10 times sine of 15, which is, of course, 2.56. 2.56 meters. So what is the vertical displacement? It's 2.56 meters. Much harder is going to be the second part of this question. What is the final velocity when the object is done sliding through the 10-meter displacement? To get this, we're going to need to look at the kinematics of the question, which is to say we're going to look at the forces and turn them into accelerations. This has a gravitational force that's attended by these downslope and perpendicular components. So we've got Fg in here, and then we've got, hang on, I'm going to draw that a little bit more outside, make it more convincing. I've got Fg there. And then Fx, the downslope force, that's kind of what I'm really interested in. And then Fy there. A note about Fy. You might notice that we do have an Fy that's diagrammed as pointing into the ramp. And yet we haven't diagrammed an opposing force. So like based on this thing, it seems like there is a net force that points into the ramp. Don't fall for it, because in actual fact, the stiffness of the ramp supplies an opposing force that keeps it from just tumbling through the surface of the ramp. So don't worry, we're not breaking the rules of physics. It's just that we're not really interested in the perpendicular one right now. We're interested in what brings it down the slope, which depends on Fx. Okay? Now remember, these are going to be proportional to the accelerations. So Fg is proportional to acceleration due to gravity, which we can simply write as g. And then similarly, Fx is proportional to the horizontal acceleration. And in the same proportion, Fy, based on this diagram, is proportional to the y acceleration, except we're going to say maybe we're not going to really pay attention to that, because we're ignoring some of the vertical stuff. With the y stuff, we're not paying attention to the force that keeps it from crashing through the ramp. So we'll ignore that one. But this proportion right here, Fg is proportional to g in the same proportion as Fx is proportional to Ax. So what that means is that trig ratios can be formed by either the F's or the A's. Because the A's are the ones that are going to be immediately useful for kinematics, let's just go right for them. That means this 15-degree angle, which is reproduced here. Sorry not to have put that in the diagram sooner, but that right there, that is our 15-degree angle. And what that tells us is that the sine of 15 And here I'm looking at this 15-degree angle, so opposite over hypotenuse. But I'm going to use not fx, but ax. And I'm going to use not fg, but g itself. So sine of 15 equals horizontal acceleration, which is currently unknown, divided by gravitational acceleration, which is known, right? That's 9.8. I'm writing a symbol for it, but we really know what it is. That means ax equals g times sine of 15 degrees, 9.8 times sine of 15. Sometimes I write the degree symbol, sometimes I don't. It's a free country. And this is 2.54. If this number looks familiar, it's because this is 10 times sine of 15. 9.8 times sine of 15 is almost exactly the same, but that's a coincidence. Don't read too much into it. It's just because this ramp happens to have a length that was almost the same number as acceleration due to gravity. That's not significant. Don't go hunting for meaning there. This is an acceleration. So we need to label it as 2.54 meters per second squared. Well, this says, what is the final velocity? Okay, now let's set it up kinematics style. I always like blue to do kinematics, just because that's the type of person that I am. We've got an acceleration of 2.54. We know our displacement is, stop, think about it. Do you want to do the 2.56 or do you want to do the 10? Think about the direction of this acceleration. This is a downslope acceleration. So you need to specify a downslope displacement. That's why this will be 10. It's not going to be 2.56. Common protest, well, then why do we have to solve for the 2.56? Because you should be able to tell that later on when you're asked about something, you need to use the correct quantity, not just parrot back the thing that you solved for earlier. Okay, so acceleration is known, displacement is known. We also are going to assume that this thing was released from rest. Was that stated? An object is allowed to slide? Nope, but when it's not stated, you can assume that it's from rest. What we're looking for is VF, because that is the question. What is the final velocity? There is an equation that involves all of these. And it is VF squared equals V naught squared plus 2A delta X. Oh, the thing we're trying to find is even isolated and everything, and V naught is 0, so we can ignore it. So this is just all kinds of nice. VF is going to be equal to the square root of 2A delta X, just taking the square root of both sides. And now simply put in the things that we know. It's the square root of 2 times the acceleration of 2.54 times the displacement of 10. So I've got 2 times 2.54 times 10, and then take the square root of that. That's 7.13. This is a final velocity. So I will specify it in meters per second, and that is the answer to the question, 7.13 meters per second. Neat, huh?